Hello everyone, welcome to my talk. Thank you for coming or for watching the video. My name is Bryan Weber and I'm going to be talking today about distributing and collecting Jupyter Notebooks for manual grading. I'm a faculty of mechanical engineering at the University of Connecticut, and I like to use Jupyter Notebooks for homework assignments and exam problems for my students. In my talk today, I'm going to tell you about my motivation for preferring manual grading as opposed to automatic grading of the notebooks. Tell you how I customize the notebooks, give you a short demonstration of the software that I've written to help with the process of producing and distributing these customized notebooks, and then tell you about how you can create your own Jupyter server extensions and customize the output of notebooks for yourself as well. So ideally, grading could be automated and we would never have to deal with it manually ourselves. However, despite the fact that there are several software packages out there, they don't quite meet the needs that I have for my class. And there are two particular problems that I've identified with these software packages. The first is that I already run a Jupyter Hub instance for my classes, which is just about all the sysadmin that I can manage. So the idea of setting up another web service plus authentication to be able to use something like NBGrader or using a commercial provider like OKPy may not be possible or feasible at my university. In addition, the typical style for the automated graders is to have assertion checks that require multiple inputs or identifying multiple inputs with their associated outputs so that students just have to code the correct algorithm and then the test will ensure that they didn't return the single correct answer, right? That they actually implemented the algorithm properly. So the problem that I have with that second one is that for the domains that I work in, and in particular in thermodynamics, changing the input conditions can substantially change the approach to the solution that you have to take. So identifying multiple inputs or outputs may not be possible for particular problems. On top of that, if I want to assign partial credit to my students' work, I still have to have some manual input even when I'm using those automated grading solutions. So my thought is, let's just do the whole thing manually in kind of an old school way, and we'll go from there. That said, I still don't want to have to manually convert my notebooks into different formats, so I'm still going to use some software to work with the notebooks. And in particular, I have 4 requirements that the software should fulfill. The most important one is that it should have a single source notebook. I don't want to have to update multiple notebooks when I change, say, the input for a particular problem or change the defined values for a particular problem. I want to have one source notebook that has the problem statement and the solution in it that gets converted automatically into the sanitized output that doesn't have the solution that we distribute to students for them to work on, as well as a complete output including the solution. As I said, I want to avoid the assert style tests and avoid setting up another web service. And then the last requirement that I have is I want students to be able to download a PDF of their notebooks in a nice format so that we can do the grading on those PDFs. PDFs are a very convenient interchange format. They're more convenient than the notebook files because the TAs or the graders can just directly see the PDF. They don't actually have to be running a notebook server themselves. So I've developed a pair of software packages that accomplish these requirements. They're both open source BSD license packages available on GitHub. The first is a Python package called thermohw, which takes a folder of input notebook files and sanitizes them to produce the file that we send to the students and also produces the solution version. The other is called convert and download. And this is a Jupyter Notebook extension, which allows students to download multiple notebooks in a single PDF. So at this point, I'll give a demonstration of how the software works, and then we'll get into some of the details, the internal details of the Jupyter Notebook extension and the customization of NBConvert. So the first thing that we'll demonstrate is, as the instructor, how you would use thermohw package. So the thermohw package expects the folders to be in a particular structure. So there should be a top-level folder called homework, and within that top-level folder there are subfolders that are numbered for each assignment, and then each assignment has one problem per notebook. So we can take a look at one notebook here. Typically, I start with the problem number and then any imports that are necessary to solve the problem. Then I give the initial definition of the problem, any of the input parameters that the students would find in the problem statement, give them the problem statement, and in my source notebooks, I use a Jupyter Notebook extension called Python Markdown, which allows me to put Python values directly into the Markdown cells. So this extension formats anything that's between double curly braces as it runs the Python code that's inside there, and then whatever the output of that Python code is, it puts into the cell. So in this case, I'm turning the value of the variable p1 up here into a string using the built-in format method. And you can see here that produces the output 100 psi. So that's a really convenient way. If I change the values in the definitions up here, it's automatically reflected in the problem statement down there. After that, the solution starts with a cell that contains the words or the symbols ## solution. And then underneath the solution, we can have different parts of the problem separated out by cells that start with ###. And then there can be markdown cells that explain the process, code cells that actually do the work of the solution. And then usually I'll put the answer to the problem in a markdown cell that's formatted with these bootstrap CSS classes, specifically the alert and alert success CSS classes. And those go on a div, an HTML div element, which is put in that markdown cell, and that's what gives it that nice green color that makes it really stand out so you know where the answer is. The other thing that we have here is an image. So on some problems, it's more convenient to hand draw a sketch for a particular process or something like that, particularly in thermodynamics. And so we can attach an image to the cell, to a markdown cell, using the edit menu and then insert image, which will actually put the JPEG, in this case, or a PNG, into the output of the cell. And that image then gets carried along with the notebook, which is very convenient. And ThermoHW will grab that and write it out to the disk so that the LaTeX converter can convert it to a PDF. So I could download this one notebook as a PDF using the download as menu and then choosing PDF via LaTeX. But I don't want to do that. I want to do all my notebooks all at once. So save this and close it out. Then I have my terminal here. And the main interface for ThermoHW is through a shell script. And so the directory that I'm in here has that homework folder, right, the top level directory there. And so the script name is called convert thermoHW, and we pass it a couple of parameters, the homework number, the problems that we want to do, and we can tell this script to put in certain prompts for the students to do particular problems out by hand and attach images of their work instead of doing the problem by code. So this script produces 4 output files. It produces 2 PDFs, one of the sanitized version to send to the students and one of the complete solution. And in the solution, actually in both of them, it replaces the Python Markdown values with their explicit values so that the students don't need Python Markdown installed in their Jupyter Notebook. They just get the values as they were written out in that actual problem. The other 2 files are zip files, which contain the sanitized and the solution notebooks for each of these problems. So we can copy the zip file for the assignment for the sanitized version. Let's just copy that into the current directory and then unzip it. So we can see there are 4 files that are produced by this conversion. And so those are in the top level directory. And so we can look again at this 4th one that we were working with before. And we can see that the problem statement is still here. All of this above the solution is all the same, except these values now are exactly filled in instead of the Python Markdown format. And then down here in the solution, for each of the parts of the solution, students are prompted to write an explanation of their process, to write the code that they need to use to solve the problem. And then in the answer cell, they're prompted to put in their answers. And this is a standard markdown cell, so we can use the standard markdown cell features. For certain problems where students are asked to upload an image, they're prompted for that as well, and they can attach the image to be able to add it to their work here. So once the students are done working on the problem, they close out all their notebooks, and going back to the tree view here, at this point they want to download all of their notebooks into a PDF so that they can submit that for grading. So they select all of the notebooks here, and by selecting those, the Jupyter Notebook extension Convert and Download is activated, and that adds this button Convert and Download Selected. So that kicks off a process in the background to convert all of those notebooks into PDF, and then put them all together into one PDF, and the browser will download that. And once that gets downloaded, then we can open it up, and just take a look at what that produced. So here's that output, and we come down to the fourth problem down here, and we can see that, as expected, the explanation that we put in, the code that we put in, and then the answer is all in the answer cell here. With that demonstration, I've been using this software for the last couple of years in my classes. It's been pretty successful. I definitely have ideas for improvements, but I'd be very happy to take any feedback that anyone has if you end up wanting to use that for your classes. My contact information is at the end of this presentation. So the next thing that I want to show is to do a deep dive into the internals of the Jupyter Notebook and the NBConvert package to see how you can implement this yourself, in case what you see here is kind of what you want, but not really. Then you'll have a little bit more knowledge to be able to approach that yourself. So the first question is, how does a notebook get converted to a PDF anyways? So when we go to the Download As menu and choose PDF via LaTeX, clicking that button triggers a JavaScript function which calls a Python class, which handles the HTTP request. Inside that Python class, there's some more code that calls the NBConvert package, and NBConvert is actually what handles doing the conversion between the notebook format, the IPYNB format, and all the other formats, export formats that are supported. So the NBConvert pre-processes the notebook, for instance, to remove the solution from the cells or something like that. When converting to a PDF, it fills in a Jinja template, and that Jinja template produces a LaTeX file, and then the NBConvert runs XeLaTeX to compile that LaTeX into a PDF, and then that gets returned to the browser. So at pretty much any step in this process, we can write our own code to interrupt and do what we want to do. We can add a notebook server extension to create a completely new route and run our own handlers. We can create new preprocessors to change how the notebook looks before it gets exported, and we can change the template that's used to create the LaTeX file that then gets turned into the PDF. So let's see how we can do all of this. Just before we get to that, I want to point out that the JavaScript that calls a download as, or is called when you click download as, generates a URL with 5 parts. And the most important part here is the route and the arguments that get passed into the Python code. So the route determines what Python code gets called. When the HTTP server, or when the HTTP request is sent to the web server, it figures out based on the URL what code it should call. And that code gets passed the rest of the stuff after that, basically, as arguments to the function. So the particular function that is called for the NBConvert package is in a class called NBConvert file handler. And this sets up an exporter, which is determined by format, the keyword argument format. And this calls from notebook node, which is a method that's implemented on all of the exporter classes in NBConvert, and basically turns the notebook into whatever output format we want it to be. So this method, the get method, handles get requests, get HTTP requests that go to the NBConvert route. Okay, so once we reach this code, the next step is to go into NBConvert and see how NBConvert turns the notebook into PDF. Before we do that, let's take a look at an IPYNB file. So IPYNB files are JSON documents that conform to a particular specification that's defined by this NB format package. And the best way I think to think of JSON documents, at least from a Python perspective, is as dictionaries and lists. So the top level structure is a dictionary, and there are several keys. There's cells and metadata and some more. The cells key is the one that we're interested in, which is a list of dictionaries. And each dictionary represents a cell in the notebook. So each cell then has its own keys. It has a type, which is the markdown or code or whatever it is. And then it has source, which is the actual source code in that cell. So the exporters in NBConvert can work with this document structure to modify it and also to fill it into templates. So converting to PDF uses the PDF exporter class from NBConvert. And this is part of a class hierarchy whose base class is the exporter class. And this follows NBConvert version 5.6. Version 6 was released very recently as I'm recording this, but I haven't updated my code yet to follow that, or to use the new version. So we're going to follow the old version in this explanation. The exporter base class runs preprocessors on the notebook, which change the cells or change the notebook in particular ways to modify the notebook before it gets put into the exporter, before it gets put into the template. So for instance, there's a built-in one that will actually execute all of the cells in the notebook. After the notebook runs through all these preprocessors, it's put into the template by the template exporter class. And since this is a LaTeX exporter subclass, then the file that gets created, the template that gets filled in, is a LaTeX file, or produces a LaTeX file. And then finally, the PDF exporter runs exe-LaTeX on that generated LaTeX file from the template. And then the bytes of that PDF are returned back to the web server, which returns it to your browser, and that's how you end up with the PDF on your computer. So if we wanted to interrupt this process or do our own thing with this process, we could write our own Jupyter Server extension. And a Jupyter Server extension is a little bit of Python code to implement our new functionality, as well as some JavaScript to add the interface elements that we need to activate this new functionality. So the convert and download package adds a new route to the web server, which is called dlconvert, and it passes multiple notebook paths into that route. Then the Python code inside dlconvert calls this get method again, which is inside a dlconvert handler class. And the get method sets up the PDF exporter and converts one by one all of the different paths that were passed in, converts them one by one into PDFs and appends them into this list. That list of bytes.io objects goes into the PDFRW package, and we produce one PDF out at the end, which is contained in this in-memory structure for the bytes.io. I have to apologize for my dog in the background there. Then we need to implement the front-end extension, which is actually what ends up sending the HTTP GET request to dlconvert. And so this has to implement the load IPython extension JavaScript function. And this has to be the outer function, which we actually return here, because this is what the Jupyter Notebook is going to go and look for when it produces this extension. Inside this function, we can pretty much do whatever we want in terms of writing JavaScript as the extension. So here this function is defined so that it creates the URL that we're interested in with the dlconvert route and all of the paths that we need. Then we use some jQuery here to create a button that people can click to download the notebooks. And then finally, in here we monkey patch the selection changed function to override the behavior when a user clicks the checkboxes for the notebook to be able to change the CSS style to display the button. So that's the notebook extension, the Python code on the back end, and then the front-end extension. So now let's take a look at NBConvert and how we can add the preprocessors and filters to be able to modify the output. So the preprocessors we use to remove, say, like the solution cells, or replace that Python Markdown output, or also to work with the images and write the images out to the disk that are attached to the cells. So preprocessors implement either the preprocess method or the preprocess cell method, or both, and then return a modified copy of the input so that these can be chained one after the other. So this preprocessor will remove the solution, everything after the solution cells. So the class is called solutionremover, and we implement the preprocess function, which gets a copy of the notebook, as well as as input, it gets the notebook itself, and then also this dictionary of resources. And so this dictionary we can use to modify the behavior of the function based on certain values in that dictionary. So in this case, we're checking if this value is false, if the value at this key is false, then just return that notebook and don't do anything more, because we want to keep the solution in that case. Otherwise, loop through all the cells in the notebook. When you find this text in the source, break the loop and replace the cells list with the list all the way up to that index +1, so up to and including the cell that says solution in it. And then return that, return NB and resources. So return the modified copy of the notebook. To set this up in the exporter, we create an instance of the PDF exporter class from NBConvert and pass this preprocessors argument here with a list of all the preprocessors we want to apply, which allows us to use the exporter and the from file name method here to pass in the notebook we want to convert and the resources dictionary to produce a solution or the sanitized version. And we can do the same thing with a notebook exporter, which just turns one notebook into another notebook. We can also change the template that's used to produce this PDF file, or other templates if we are working with a different exporter. So most NBConvert classes are configurable by this package called traitlets, which allows you to define type-checked attributes, among other things, on classes. So the PDF exporter takes an instance of a traitlets.configuration class, or .config class, with particular attributes set that allow us to control its behavior. So in this case, we're setting the PDF exporter .template file attribute to the file path of our new template, and then passing that into the exporter. The template is in the Jinja syntax, which is very similar to the Django syntax, if you're familiar with that. If you're not, that's not actually all that helpful. But this syntax allows us to extend a parent template. So in this case, we're extending this particular template, and we are modifying this block that works on Markdown cells. And in this case, we're adding this line here, which is a new function, a new filter that replaces the div with the Bootstrap alert classes with an equivalent T-color box latex style. So in this, the pipes mean that the output from the previous step is sent to the next step. So we start with the cell source and pass it through all these functions, including converting it to pandoc JSON format, which is then worked on by our convert div filter. The Python to define this convert div is down here. So in this case, we're configuring the filters on that config instance. And this is a dictionary where the name, the key in the dictionary is the name that's specified in the filter. And the value of the dictionary, the value for that key is the function that gets called. So we have here the convert div function, which applies these filters, which applies this filter function, which is called div filter, which actually does the filtering for us. So all of that together allows us to produce the PDF file that we want to be able to produce, the preprocessors, and modifying the template in that way. So in summary, the manual grading of notebooks has some use cases. I tend to prefer it for the cases that I described in my thermodynamics classes. And for those cases, PDF is pretty much the most convenient interchange format for students to turn in. To make sure that this is a nice experience for students, we'd like to be able to customize the output of NBConvert when it turns notebooks into PDF and also when it turns notebooks into other notebooks, as well as making it easy for the students to download a PDF copy of all of the notebooks associated with a particular assignment. So we saw how to customize all of that behavior using the Jupyter Notebook server extension, and then also preprocessors and filters and new templates for NBConvert. So with that, I'll thank you very much for your time. My contact information is here. My email address at GitHub, I'm on Bryan W. Weber, and the URLs for the 2 packages that I talked about. Thank you, and have a great rest of your day.